Hi everyone. In Chapter 4, we're going to be learning the basics of graphing lines. So in the first section here, we're going to be talking about the coordinate plane. You guys have likely learned about this before, but really want to emphasize the vocabulary so that we all are using the same terminology when we talk about the coordinate plane and then going further with graphing. So first of all, when we talk about the coordinate plane, this is an example right here. And really, the coordinate plane is just made up of two number lines. So you can see I have a number line here, and then a number line here, right? So it's made up of two number lines. Okay, so two number lines, and we'll say that intersect at a right angle. Okay, and that point where they intersect, so right here, so I'm going to make a dot here, this origin here, that point where they intersect is called the origin. Now, when we start talking about the coordinate plane in graphing, even though we initially defined this as two number lines, we don't call them really number lines anymore. We're going to refer to them as the axes. So we have the x-axis, right? So that's going to be our horizontal axis. And then our y-axis here is our vertical axis. So far the important things, we have our x-axis, our y-axis, and then the origin is the point where the number lines, or I'm going to say really now, it's a point where our axes intersect in the coordinate plane. So another important term we need to know is a quadrant. Quadrants are just the four sections of the coordinate plane. And we have a really specific way that we number those sections. So quad obviously means four. So we start up at the top right-hand corner here. This is quadrant 1, and I'm using Roman numerals here. So quadrant 1, and then we go in a counterclockwise direction. So I have quadrant 1, this is quadrant 2, quadrant 3, and then quadrant 4. Those are our four quadrants, and a lot of times we'll use those to describe where points are located in the coordinate plane. Now, ordered pairs, those give us the location of a point in the coordinate plane. That's all that ordered pair is doing. That ordered pair is made up of an x-coordinate. So I'm going to say the x-coordinate is the first coordinate in the ordered pair. And our y-coordinate is the second coordinate. So when we talk about an ordered pair, we write those in parentheses always. Our two coordinates are going to be separated by a comma, and we have our x-coordinate and our y-coordinate. Now, one thing I want to bring up here, the x-coordinate, it's the first coordinate, and it tells us whether to move right or left. And we'll look at that in a minute. And then our second coordinate, it's going to tell us whether to move up or down. And we'll talk about what exactly that means in just a second here. So that's our main vocabulary we have for right now. And we'll be using that all throughout this chapter as we go through talking about graphing. So the first thing we need to be able to do right now is to be able to actually plot points in the coordinate plane. And so we're going to get some practice with this now. The biggest thing to remember is that when we're plotting points in a coordinate plane, we always start at the origin. So let's take a look at what that might look like. So the first point we're going to plot is point A, and its coordinates are -2, 3. So it says to plot the point A, we're going to start at the origin, just like we said. So I know the origin is this point right here where my x and y axis intersect. Now, we said the x-coordinate tells us whether to move right or left. In this case, since my sign is negative, I'm going to move to the left. So I'm going to copy that in purple, and that tells me to move to the left. So from the origin, I go to the left 2. Now, we said the y-coordinate tells us whether to move up or down. Since this is positive, we're going to move up 3. So if I were to plot -2, 3, I'd move to the left 2 and up 3. I'm going to plot that point, and then I'm going to label it point A. Okay, so again, we move 2 units to the left and 3 units up. Okay, so let's look at another one. So to plot the point B with coordinates 3, -4, again, we're going to start at the origin. We're going to move 3 units, and in this case, since B is a positive, or my x-coordinate is a +3, I'm going to move 3 units to the right. And now, since my y-coordinate is negative, I'm going to move 4 units down. So again, starting at the origin, I move 3 to the right and 4 down. And again, I label that with my ordered pair. So for the last one, I would recommend that you give a little pause here. Try that on your own, and then we'll check it. So for point C, again, we start at the origin. Now, my x-coordinate is 0. So I'm going to move 0 units really to the left or right. So I'm going to stay right where I am. And then since my y-coordinate is -2, I move 2 units down. So again, I start at the origin. 0 tells me to stop. I stay where I am. And I just move 2 down. So you can see that point ends up on the y-axis. And then I go ahead and label it. So that's how we plot points. Now there's a couple questions down here asking us what quadrant these points are in. So we have to remember, back up to the top, remember we said to label our quadrants. We start on the top right, and then we go counterclockwise. So 1, 2, 3, and 4. So point A, we can see is in quadrant 2. Point B is in quadrant 4. Now with C, we have to be careful because it looks like it's right in between 3 and 4. But when that happens, we actually say point C is on the y-axis. It's not in a quadrant, but it's on the y-axis. All right, so let's go ahead and turn the page. Okay, here's a little checkpoint. Again, I would recommend pausing and then checking back to see if you're correct. So point A is -3, -2. That means I'm going to go to the left 3, down 2. I always label my point with the letter. Point B is 4, 0. So that tells me to go to the right 4, but then 0 spaces up or down. I'm going to stop right there. Point C tells me to go 1 to the right, up 4. And then D, My negative 3 tells me go to the left 3. Positive 2 tells me to go up 2. Now, we're going to look on this next part and talk about the quadrant. So sometimes it helps me to just imagine here in coordinate plane. I know this is quadrant 1, 2, 3, and 4. So now, if I have to think about the quadrant that negative 6, 7 is, I know that to plot that point, I would start at the origin, go left 6, and then up 7. So if I can visualize that, I know that's going to put me in quadrant 2. And here's where signs become really important. In this case, I have negative 6, negative 7. So that would tell me to start at the origin, move left 6, and then move down 7. So in that case, I end up in quadrant 3. For 6, negative 7, I move 6 to the right and down 7. I end up in quadrant 4. And then for the very last one, as I move over, I'm going to go right 6 and up 7, and I'm going to end up in quadrant 1. A good way to think about this too is if I'm in quadrant 1, I know all my x values are positive and my y values are positive as well. And so that matches here with problem number 8. Both of my signs were positive. I'm in quadrant 1. In quadrant 2, my x values are negative and my y values are positive. Again, matches problem number 5, a negative x and a positive y. We could complete this here. In quadrant 3, I have a negative x and a negative y. And then in quadrant 4, I have a positive x and a negative y. So that could help you quickly identify what quadrant you're in. So those are the very basics of how we plot points and how we determine where they're located in the coordinate plane. So we're going to talk briefly here about scatter plots. And all a scatter plot is, it's just a graph of ordered pairs that shows the relationship, whoops, skipped a word there, that shows the relationship between two sets of data. Okay, it's just going to show us how some things are related. And the correlation is exactly what's going to tell us how they're related. It tells us the relationship or tells us how the data is related. And we'll look at some specific examples to talk about this in a second. Okay, and then last we'll be looking at lines of best fit. And this is just a line on a graph that best represents the data. So let's take a look at this more specifically. So here you can see I've got 3 different graphs. Again, these are scatter plots because it's just a graph of some ordered pairs. There's some data set and we've graphed all of these ordered pairs. But if I look at these examples, I can tell in this first example that as my x value increases, my y value increases too. So if I look, the data seems to be going in an upward direction. That's what we call a positive correlation. In the next one, we have the opposite. Now as x increases, y tends to decrease. So that's moving in a downward direction. That's what we call a negative correlation. In this last example, clearly there's no real pattern there, and that's when we say there's no correlation between the data. So if I look at this example here, It says the data here is showing how the number of hours worked and the amount of money spent on entertainment are related. So I have some data sets that have been plotting here, comparing the number of hours worked to the amount of money spent in entertainment. So for example, if I look at this point here, it says for that person worked 2 hours and then spent $5 on entertainment. And so we've plotted a bunch of points. And so it says to draw the line of best fit for the data points. And again, we're not looking for exact, we just want a line that represents this data. So all I'm looking to do now is draw a line that kind of goes through the middle of the data. I wouldn't draw it going up this way because that doesn't show the pattern of my data. I'm just going to try to follow kind of along the middle here. So I might draw a line that looks like this. So some of the points are above that line and some are below, but in general it shows the direction or the trend in that data. That's what we're talking about when we're talking about the line of best fit. Okay, so one more example to go through here. So here again we have a scatter plot. Now the data that we're comparing are the time spent texting and the time spent exercising. So if I look at this graph, and actually we're going to get into this in the questions, but before I even get to the questions, I'm looking at the graph and I'm noticing that this data, it seems like as I spend more time texting, my Y, the time spent exercising, is going down, which makes sense. There's only so many hours in the day, so if I'm spending more of that time texting, I have less time potentially to spend exercising. So I recognize this downward trend as what we said was negative correlation. So let's see what we have to answer here. It says for these 25 points, as the time spent texting increases, the time spent exercising, well, we already said that tends to decrease. It's going down. So for these students, there is we said, negative correlation between the time spent texting and the time spent exercising. So now in this example, you can see they've already drawn in that line of best fit. That's what that line is here. So it says, we would predict that a student texting for 6 hours would exercise for approximately how many hours? So what I need to do is, here's my 6. My time spent texting is 6 hours. So I'm going to go up to that line of best fit, and I find that point's here. So if I look across to my y-axis, it looks like if I spend 6 hours texting, I spend just over 4 hours exercising. And again, that's in a whole week. So let's see. At 6, I'm looking for something above 4, below 5. So it looks like 4.3 is going to be the best approximation. So that's the first piece of the first piece of chapter 4. So again, just basics. Can we graph a point? Can we locate the quadrants it's in? And then some basic information about scatter plots. So you'll be practicing that next in the homework.